Hello. So in this video, we will see the load balancer error codes. Okay. So let us see one by one what happens. Successful request. Suppose if you have a successful request, then the code you will get will be in 200 terms. Then unsuccessful, if it is on client side, then it will be in the 4xx code format. Suppose any of the services which are unsuccessful at the client side, like if it is error 400, it is bad request. If it is error 401, it is unauthorized. Then 403 is forbidden. 460 is client closed connection. 463 is X forwarded for header with less than 30 IP, okay, which is very similar to multi request. You don't have to remember all these, but you just have to remember that 4xx code is actually for the unsuccessful requests at the client side. Okay, so the unsuccessful request at the service server side will be in the format 5xx, and suppose an error, internal server error, would mean some error on the ELB itself in the elastic load balancer itself, and if it is the error, then you will be getting 5xx code error. Error 502, you will be getting if there is a bad gateway protocol. Okay. If service is unavailable, we generally get an error of 503. So basically, that excess X after the 5 is the numbers 0203, whatever it is. So 504 will be for gateway timeout, probably an issue with in the server, and 561 is unauthorized server. So that is how you will get your errors. Let's move forward. Next is load balancers monitoring. So all load balancer metrics are directly pushed to CloudWatch metrics. Metrics, that is all the data what you want to fetch about your load balancer will be fetched or will be pushed to CloudWatch metrics. If you have any backend connection errors, healthy host count or unhealthy host count, that will be counted. HTTP code in the backend, it will be in the code at 2xx. Successful request will be 200. Then HTTP code in the backend 3xx, it will be redirect request. 4xx will be client error codes. Next will HTTP code. 5xx will be server error codes, which we saw just in the previous slide. Latency, request count per target, search queue length. All these are important metrics that could be watched over, which help to scale out ASG. Max value is 1024. Spill over count, you generally don't want this to be more because the total number of requests that were rejected because the search queue was full. Because suppose you are requesting something and because there is on one request already in the line in the queue, then your another request is being rejected. That type of thing you don't want in your load balancers. Suppose this is your application load balancer. Here are your like instances in TG1, TG2, TG1. You have two instances which are unhealthy and one instance which is healthy. And other in TG2 or target group 2, you have three healthy instances. So total health count will be 4 and unhealthy host count will be 2. So that matrix would be counted and that would be pushed to CloudWatch matrix. That's it. Next is application load balancer request tracing. So request tracing, basically each HTTP request has an added customer header or custom header. Uh, like suppose this is your custom header XAMZN trace ID. Example XAMZN trace ID, and then this is your header, and this is what it will be like. Dot root is equal to 1 minus whatever the number is. Yeah. This is useful in logs actually when you have access logs or other logs when you save those logs. So this is actually useful in logs. Distributed tracing platform to track a single request. Suppose if you are requesting something, that access log will just that log would be counted that yep you have requested something. So a log is made, access log is made, and then you have to go through that. Application load balancer is not yet integrated with X-Ray, so it won't be able to access that. So that's it for today. Let's meet in our next video. Till then, thank you.